When it comes to cybersecurity for embedded systems, complexity, cost, and compliance are often the biggest hurdles. In this video, I will walk you through how our security test environment, HydraVision, helps overcome those challenges. We will mainly focus on the HydraVision user interface, so you will get a clear picture of how it works in practice and what it can do for your team. Hey again, I'm Dr. Nils Weiss, CEO and co-founder of dissecto. Today I will walk you through HydraVision, our security test environment that streamlines and automates security validation for embedded systems. HydraVision is designed to make compliance with diverse industry standards more achievable and more transparent than ever before. Unlike traditional testing setups, HydraVision offers early vulnerability detection, remote testing capabilities, and structured reporting, all in a scalable and cost-efficient solution. To interface with your device on the test, HydraVision offers you three options. The first kind of interface is our Hydra Probe, where you can connect a ECU directly. The second interface is our HydraProbe Mobile, which is a phone-based system with a OBD plug that can connect to a full vehicle and where you can perform full vehicle scans. And the third option is a Docker environment that you can start and launch on existing systems with standard CAN interfaces. Let's have a look on the HydraVision UI. Here you can see our probes overview, where you can see multiple different probes connected to the system on completely different locations. This shows you the remote capabilities of the system. Probes can be everywhere on the globe. Here is our target overview page, which at the moment shows two different ECUs, a gateway from Audi and a gateway from BMW. The only thing that you need to do in order to start testing a target, you need to configure the so-called context. Here is the context of our BMW gateway, which shows our interfaces, for example the Ethernet interface, where the gateway is connected to the probe. Also, we have a power supply unit where we connect the target to, so that the probe can power our target. The next thing that we have in the UI is our test case library. We provide more than 100 template test cases that you can directly use and customize to your needs. For example, here's an ISOTP scan, and I can get a description, a threat description, a mitigation description, and potential CVE descriptions from this test case. Additionally, with the arguments that this test case requires, for example, a power supply and a CAN socket. So this is the documentation of the test case. And now I can take this test case and change the source code of it, because we provide you these capabilities. Take any of our test cases, customize the test, and you have a new test scenario. Here is the source code of the test case. Also here in this section, we have the documentation of the test case. Every test provides a logger, so you have some logging capabilities. And you can directly tell the test case what kind of objects does my test case need from our target context in order to be executable. So for example, here we have the power supply and the UDS endpoint. The next unique feature that we have is our test case execution. Now let's jump into our Audi gateway. We just configured the context here. So we can see our CAN bus, CAN socket, and power supply unit. So I'm gonna select those context entries. And if I don't know what to do and where to start first, I can just select all of our test cases from the library and ask the system to generate me test case execution definitions. We call them execution definitions because those are the direct mapping between a test case and a specific context. Here we see in this table the test case and the context which is associated to this. In order to start with something, we perform now an ISOTP scan on this ECU. Now the ISOTP scan is created and is already running. If we want to see what's going on here, we can click into the UI and see some live data in our result page. Here we see live the current consumption of the device under test, and we can also access all the loggers. So on this ECU, I was already executing a few test cases. You can see a list of test cases here that were successfully performed in this ECU. And in order to know what was done on this ECU or what tests and jobs were executed, I can click into the details page of every job and see the results of this test case. So this was a UDS system state scan, which is an initial test case to scan the entire ECU for its individual UDS sessions and maybe also its security levels if you have provided a security access algorithm. And this page here shows you the results. We have a high-level result here. So this state scan identified 4 different states, and we found already one problem here, which we consider as a vulnerability potentially. Additionally to this information, we have the power trace over the entire execution. And if we want to see certain specific data, we can enable the logging systems. So for example, I enable the Skeppy logger here, and I can zoom in. I see the log messages associated with the selected time frame. And I can go into inspection and debugging of the system, of the test case execution, in order to find problems if something crashed in the meantime, or if I need to diagnose something. After we have executed all test cases that we want to perform on our device under test, we can click on Generate Editable Report, and then all of those jobs, including their results and their log metadata, is put into a repository where we can edit the report and then create a PDF out of it. Let's have a look. Here's our report for our BMW Gateway ECU. Once I've created the report repository, I can edit this repository as we are used to it from our test cases. And what you get here is a auto-generated report, which is a markdown file. So this is our test report of the BMW Gateway ECU. And here we have the description of each individual test case, the summary of the test case, also the result table, and some additional informations such as when the test case was started, which was the probe that we used, what was the target, and so on. Also, we have a power trace here, and we have log messages, the default log messages. And in this way, it's fully traceable what was actually executed on the system and what was the configuration of the system. To make the life of penetration testers more easy, penetration testers find all the assets, as for example loggers, here in the metadatas, and any log message that was generated during the test case execution can be copied and used as a proof. As for example, let's take a look. Here we have certain HydraVision packages from this ECU. We're going to copy this line and we can use this directly, copy and paste in our report. Let's see. Another proof, this ECU is using HydraVision. And here is my line to document this. But that's not all, because we have also integrated AI capabilities into our test case reporting. We can use ChatGPT, for example, to analyze log data. Here's the ChatGPT plugin, which works with any OpenAI API compatible large language model, even your self-hosted large language model in your company. So you don't leak any data to OpenAI if you use your own models. Let's have a look on some complex log file. Let's pick one, for example, the UDS state scan here. we're gonna pick the logs, and I'm gonna pick the SCAPI logging. So here's the SCAPI logging of the entire execution, more than 400 lines of log data. And I want to quickly ask ChatGPT to tell me all the errors of this log file. Summarize all errors of this log file in Markdown. And let's see ChatGPT working. Here we go. We have a few general errors, broken pipe errors, bad file descriptors, negative file descriptor errors, and test case specific errors. For example, some warnings, some timeouts, etc., etc. Fine. After this change, again, I'm gonna commit this change. I'm done with reporting now. And I can ask the system to give me a PDF out of it. Here's my PDF with a lot of data, with my power traces. Let's see, my GPT summary. And I can send this report now, this PDF, to my colleagues or archive it. But there's one feature missing, because what we have is a very unique remote debugging feature. I can pick an ECU, or more precise, a test case, and every test case that I have executed can be started in debugging mode. So for example, let's take this power check, which is a very simple test case. I can start this test case in the debugging mode. Here we go. And once I click on this bug, I get spawned into the remote debugger, which is again my IDE, but now I'm directly connected on the probe where the device under test is connected to. To prove this, you know, I'm a hacker, I like root shells, and here is my root shell to the Hydra probe where the BMW gateway is connected to. In this debugger, I can set breakpoints at any place, and I can start now this test case in debugging mode. This takes a little bit until the probe and the test case environment is up and running, but then I get spawned into the breakpoint and I have full control over all the interface objects and the ECU. Let's have a look. Here we go. Now I'm in the breakpoint with the ECU directly connected to, and I have, for example, control over this supply variable. So I can just go here and manually turn on the ECU by saying supply on. To prove this, here you go, we look at the details page, and here's the power trace of my supply on command. Also, I can turn the supply off. Again, now power consumption is off now, since I turned the power supply off. And I can continue my test case execution by pressing the play button in the debugger. Thank you for joining me on this walkthrough of the HydraVision UI. If you're looking to streamline your cybersecurity testing process and stay ahead of the compliance requirements, HydraVision can make that journey smoother for you, more transparent and more cost efficient. To learn more or to schedule a demo, visit us at dissecto.com or get in touch directly via phone or email. We're looking forward to supporting your cybersecurity goals. Until next time, stay secure.